what is going to be the behavior in our network if, as the PECE routing protocol, we actually used OSPF instead of using some other protocols. So what I have configured in the meantime is actually an OSPF process here, which is running on R5 as OSPF 57. Here it's OSPF 1, and this is going to be in area 0. On this side, this is going to be OSPF 68 on R6 and OSPF 1 on R8, and this is also running in area 0. So I have configured that between these interfaces here, and I have also redistributed OSPF into MPBGP, and I have redistributed from MPBGP into OSPF. So this is the setup that we have right now. So let's take a look if this actually works. So I'm going to go to R7, and I'm going to run very simple ping source loopback 0, and I can ping from R7 to R8. This is no big deal. On R8, ping from R8 to R7 also works. So this is the running configuration of R7, and as you can see, it's a very basic. I'm just running OSPF 0 on all interfaces. This is the configuration on R5. So show run VRF shows me that here I'm running OSPF 57, and when you're configuring OSPF or VRF, this is what you need to specify. But mind you, you just need to do this once. So any subsequent reference to OSPF 57 will actually take you into this process in VRF. So you don't have to type router OSPF 57 VRF-A every time, just the first time when you actually create the process. Now, the reason why I used OSPF 57, or why I didn't run OSPF 1 process, is because I already have OSPF 1 running in the main routing table. Now, even though OSPF process, generally speaking, is not relevant for the VRF routing, or shouldn't be relevant for VRF routing, I should say, you cannot have the same process ID on multiple processes. So I need to have a separate process ID for this process running in VRF. But because the OSPF process should be locally significant, I can run any number here without any consequences, or should be without any consequences. So here I have redistributed BGP subnets, so let's go back here, and also in BGP I have redistributed OSPF 57 into the VRF. So I have pretty much replicated the configuration that I already had with EIGRP. On R8 side, configuration is just about the same. I have OSPF process 1, I have the network statement running on all the interfaces, and on R6 I have pretty much the same configuration, except on this side I have actually used OSPF process 68. Again, I have redistributed from BGP into OSPF and from OSPF into BGP, and hence I do have reachability end to end. Now, if I take a look at R7, at show IP route OSPF, I am getting two routes. These routes here are external routes. Now, it's perfectly understandable why these are external routes. They are external routes because at this point here, I have redistributed them from multi-protocol BGP, and I have actually injected them into the OSPF process. When we redistribute the routes, this router here becomes the ASBR, and it injects the routes as type 5 LSAs. This is all perfectly fine. Now, the task in the lab says, make sure that 10008 and this route 10680/24 is visible on R7 as inter-area route. So not as an external route like we have now, but as the inter-area route. I can see a couple problems with that. One is this is area 0 and this is area 0. If I ran, let's say, a tunnel or something in between them, the best thing that I can do is make them intra-area routes. But how can I have divided area 0? I cannot have that. Well, you cannot have that in traditional OSPF, where all areas must connect to area 0. When you are dealing with OSPF in MPLS VPNs, there is one more level of hierarchy. So in traditional OSPF, what we have is the route of hierarchy where you have the backbone area, and all other areas must connect to the backbone. So if you had multiple backbone area, non-backbone areas, they would all need to connect to the same backbone area, right? So all these here would need to connect to our common shared backbone. So this would need to connect here, this would need to connect here, and let's say that we had another area here that would need to connect to that backbone area. Why? Because we need to have that hub and spoke communication between the areas, right? So this is in traditional OSPF. Now, OSPF in MPLS VPN scenario actually introduces one more level of hierarchy. Because here in multiple sites, multiple independent sites, we can actually have the backbone area that connects to non-backbone areas. So we can have this set up in multiple sites. So we can have multiple independent backbones in our case. Now, all these backbones are connecting to something that is called super backbone. Now, super backbone is just a fancy name for another protocol that is also commonly called multi-protocol BGP. So multi-protocol BGP acts as something that we call super backbone. Now, the rules of hierarchy for OSPF in MPLS VPN are: if there is a backbone in the site, so backbone here, I mean area 0, it must directly connect to the super backbone. So if we have area 0 in a site, it must be directly connected to the super backbone, or it must be extended to it. Now, how do we extend it? Either using virtual links or GRE tunnels. Now, in plain English, this means that area 0 must be present on the PE device inside VRF. Now, rule number 2. If there is no backbone in the site, it can freely connect to the super backbone. Now, inside the site, the rules still apply. Non-backbone areas must connect directly to the backbone. But we can also have another site that doesn't have area 0, and in that case, it's okay for this non-backbone site to actually connect directly to the super backbone. But if you do have a backbone in the site, if you do have area 0, you can connect to the super backbone. Now, if we have this level of hierarchy, these levels of hierarchy, then it is entirely conceivable how we could actually get inter-area routes. Now, the way we could get inter-area routes is we could inject them here from this, say, backbone area, we could inject them into the super backbone, and when they are advertised back here, they would simply be injected as type 3s. Now, we all remember the split horizon rule, that when we are receiving the type 3s from a non-backbone area going into the backbone area, they're going to be rejected. But not in this case. In this case, it is okay, because super backbone is that. It's just an area that sits above the backbone. So our level of hierarchy is still maintained. The split horizon still kind of works. But the problem here is that I already have this setup. Right? My setup is actually even simpler, because in my setup, all I have is super backbone, and 2 backbone sites. So I don't even have non-backbone areas. So what I have here is I have the route that is advertised to super backbone, and it's coming in here, but it's coming as external. Well, it's coming as an external because my OSPF treats this site and this site here as separate domains. So this one here is going to be, let's call it red domain, and this one here is going to be a blue domain. Now, these domains actually have their own technical identifiers. Let me show you that. So I cannot see that on R7. This is all PE based. So this has nothing to do with customer edge devices. This is all happening on the PE. So now I'm on R5. If I do show BGP, VPN v4, unicast, VRFA. So I want to see the route for 10.0.0.7. Take a look at this. It says OSPF domain ID, and then I have this large number here. Now, this is the domain ID type, and it's one of those situations where, you know, sometimes that you have known something and you have forgotten it, and then you tell people, yeah, I've known this sometime in the past. In my case, I have never actually known what the domain type 5 means. You know, I know many things, but this is one of those things that I just never actually bothered to figure out. Also, I'm not entirely sure what this 0200 means, but I don't think that this holds me against knowing what this here is. This here is the actual value of the domain, and we can see that it is a hex value 00000039. Now, important thing here is 1, 2, 3, 4. These are 4 octets, 4 bytes, 32 bits. So this 39 here is an actual value of the domain. So let's go here, and so this would be the domain that is on the red side. So it is 0x39, which incidentally, if you translate, will be 57. And here you might be seeing where I'm going with this. And this is the domain that is identified for our 8th route, or the route learned from R6. So my blue domain here has the value of 0x44, which incidentally is value 68. In other words, this was the OSPF process ID on R5, and this one here was OSPF process ID on R6. So if you remember back in those days of CCNA when you were learning, or CCNP even, when you were learning about OSPF, and when the books told you that you can use whatever process number you like, it's locally significant and it doesn't really matter. Well, as it turns out, sometimes there are situations when this process number actually does matter. So now, because my OSPF process on R5 here, so this is happening on R5, thinks that the routes arriving from R6 going into the super backbone and back into R5 are actually from a different domain, it is going to inject them to other routers. It's going to inject these routes from the super backbone as external routes. Now, if my domain here and my domain here actually matched, when these routes would have been inserted, they would have been inserted as inter-area routes. So I have to find a way to match this domain to this domain here. Now, the easiest solution would be to actually change the process numbers, but let me show you the solution without actually changing the process numbers. So I'm going to go to R5. Again, a reminder, this is strictly happening on provider edge devices. Customer edge devices, in our case, R7 and R8, they have nothing to do with this. So on R5, I'm going to go into router OSPF 57, and here I can configure the actual domain ID. Now, I can say that I don't want any domain ID, or I can specify the type followed by the value, or I can simply specify the domain ID. Now, let's use 56, 56, 56, 56. Now, it helps if you clear IP route, so clear IP route VRFA star. This will speed up the process just a little bit. So here, if I take a look at these routes now, this is the domain I have. 38, 38, 38, 38, which in hex is really 56, 56, 56, 56 decimal. So now I'm going to do the exact same thing on R6. I'm going to go to router OSPF 68. I'm going to say domain ID 56, 56, 56, 56. And of course it helps if you type correctly. Again, clear IP route VRFA star, just to speed things up a little bit. So if I go to R5 now, I will see, okay, maybe I didn't speed them up enough, so let's wait just a second. Oh, there we go, now it happened. So this is route for 7, this is the domain, and this is the route for 8, and this is the domain. So now I can see that domains actually match. If I go to R7 and if I do show IP route OSPF, now these routes are inserted as inter-area routes. So as you can see here, I have done no changes on R7 in the meantime. I have done no changes on R8 in the meantime, and yet here the routes are now showing up as inter-area. Because now what I have done, now my OSPF on these two routers is treating these two here as the same domain. So this is now the same domain. So on R5, this is the same domain, two sites, but the same domain. So now the routes that are being injected are actually inter-area. The question that I had there is, do I need to change the domain ID to match for inter-area routes to happen? The answer is yes, because if the domain ID on this side and this side doesn't match, the routes will be injected as external routes. If you are receiving the routes with the same domain ID as is configured locally for that process, if that is the case, then the routes will be injected as type 3 routes. So if the domain IDs don't match, external. If they do match, inter-area. Now that this is clear, I'm going to make our example here just a little bit more complicated. So our example involved a couple of routers, and they were all running OSPF and MPLS and everything that we've done. So I'm just buying myself time now because I want to drag one other thing here into the mix. So this is the new network here that we are going to be running. So the only change that we are going to have here is now that there is this link between R7 and R8. So we are still running OSPF here. So this is OSPF area 0. We are still running OSPF here. This is still OSPF area 0. Now, what I want to run here is also OSPF in area 0. And I'm going to repeat that what I'm going to show you next is completely unrelated to the domain IDs. So they are now completely irrelevant. I was doing that. That was one exercise. This is now completely unrelated problem. So let me bring my routers in, and I'm going to bring the link. So interface fastening 01, no shutdown, and the link here, interface fastening 01, no shutdown. So this is the configuration that I have on fastening 01, and you can see that these are configured as point-to-point. Again, this is also irrelevant. The only reason why they're configured as point-to-point is so that my OSPF could converge maybe a little bit faster than if they were just configured as broadcast. So again, fastness 0.1 on this side, and on this side, of course, I haven't configured it, so really so much about faster convergence. So let me then remove it on this side here. So just to have some consistency. I don't know why it wasn't configured on the other side. So, so if I do show IP OSPF interface is brief, I'm now in a wait state, so I need to be patient for a little while. So now we have patiently waited for the wait time to expire, and our OSPF here is now converged. So what we have is area 0 here on the back, and we have our super backbone or our MPBGP here. So this is where we have our super backbone or MPBGP. Now, my task is very simple. This link here between R7 and R8 is extremely expensive. What I want to do is I want the traffic between these two loopbacks to actually take this path here. So instead of taking the shortcut link, the backdoor link here, I want to take this traffic to go across my MPLS cloud. Now, let's take a look at what's the situation right now. So if I do show IP route OSPF, I will see that my path to reach the loopback 0 of R8 is actually now using that backdoor link. Why is it using that backdoor link? Well, because it probably has lower cost. It has cost too. So let me address that right away. I know the solution. This is going to be an easy one. This is the easiest task in the lab. I'm going to say IP OSPF cost. What is the maximum cost? 65,535. Yeah, that'll do it. So I'm going to do show IP route OSPF, but I need to wait maybe just a couple of more seconds. So about now, if I take a look at this, this didn't quite work. I'm still using the backdoor link here, and the cost is now 65,536. Why would that be? Well, we have to go back to basics of OSPF. Now, the basics of OSPF say that the routes are divided into 3 categories: internal routes, inter-area routes, and external routes. Now, this is the order of preference, right? So if I have an internal route, no matter what the cost on it, it will always be better than the inter-area route. So if I go back to this example that I have the super backbone, and I have a backbone here, and I have a backbone here, and these are my connections. Now, this route here, learned over this backbone link, will always be better than the inter-area route that goes this way. So this route will never be used as long as I'm getting the route here. But this is a backup link. I can't just get rid of this link. I still need to have this route in my database, but I have to find a way to actually prefer this path here. What I need to do here is somehow interconnect my 2 sites. So these are actually 2 sites, so there is a separation here. So I need to find a way to interconnect these 2 sites through the super backbone area in such a way that these routes actually show up as internal routes on this side. Now, in regular OSPF, if I had area 0 and I had area 50 here and I had area 0, I could always run a virtual link here. Now, the problem with this approach here is that super backbone here is not an OSPF area. Now, there are no LSAs in this area, so virtual link, unfortunately, is out of the question. But despair not, there is another solution. That other solution is very similar to the virtual link, but it's not exactly the same, and it's called the sham link. Now, sham link, and I am again going to do my emphasis thing. Sham link is quite possibly the most complex thing that you might be asked to configure in the lab. Now, on its own, the configuration for the sham link itself is incredibly simple. It's a one command line. It's just area X sham link source destination, done. But what you need to have in place for sham link to work is an incredible set of prerequisites. You need to have IP routing in your backbone set. You need to have a fully functional MPLS. You need to have a fully functional MPLS VPN. You need to have a fully functional PE-CE routing, and you need to have a full reachability between your PE and CE sites. Then you need to have an operational backdoor link. You need to have operational OSPF on the backdoor link. You need to have a redistribution between BGP and OSPF in place. Then you need to create new interfaces on PE routers. Those interfaces must be advertised in BGP, but not inside OSPF, and they need to be inside VRF. Then you need to have reachability between those loopbacks. Then you need to advertise. Then you need to create a sham link, and then you may need to perform traffic engineering. Try to repeat that. Well, you see what I was talking about. It's an incredibly complex set of prerequisites, incredibly complex set of things that must be in place for sham link to even have a hope in fixing the problem. So that said, let's write some of those down so that you have at least some steps, some checklist of things that you might need to do when you are implementing sham link. So my assumption here is that backbone IP routing is in place, that MPLS is in place, that MPLS VPN is in place, that OSPF as PE-CE is in place, that OSPF as CE-CE is in place. So at this point here, you're actually starting sham link configuration. So these are the prerequisites. So sham link steps. You need new loopback interfaces on your PE routers in VRF. So not in the main routing table, but in VRF where you're trying to solve this problem. Number 2, loopbacks must be advertised into multi-protocol BGP, but not in OSPF PE-CE. Number 3, PE router must be ABR. Actually, this step is, okay, must be ASBR. The best way to ensure that PE must be ASBR is to actually configure something to redistribute, to actually redistribute from MPBGP into OSPF. Now, if you don't do this step, the OSPF process on the PE device will not even attempt to form a sham link. So it's very, very crucial that PE is considered to be an ASBR. Now, in most cases, you don't actually have to worry about this because you already have the redistribution between OSPF into MPBGP. This is how you built your MPLS VPN to begin with. Now, but I have seen some people who try to be very, very pedantic about their configuration, and they realize, oh, okay, I have a sham link there, so that I don't actually have to redistribute. So they remove that redistribution statement and basically they bring down their sham link. So leave that redistribution in place, don't touch it, just make sure that your PE is the ASBR. Now, once you have this in place, what you need to do is actually build sham link between your loopbacks. And finally, you may need to perform some cost adjustments. So some cost modifications must be done to accommodate for the solution. So these are the 5 steps that you need to do to build your sham link if you already have these prerequisites in place. So let's build a sham link and in our network and try to solve the problem of getting the traffic from loopback of R7 across our MPLS backbone over to R8. So what I'm going to do next is I'm going to start with my steps. So I'm going to keep this here, so just so that we can reference what are the steps that need to be done. So I'm just going to resize this so that I can have maximum space, but I will need, I believe, the full size of this notepad right now. So I need to create new loopbacks. I'm going to start from R5. So I'm going to say interface, loopback, let's call it 56. This needs to be in the VRF. So which side are we using the new configuration? I believe it was on R6. Show run VRF. Yeah, it was R6, but okay. So here I will say IPVRF forwarding. So let me just bring that thing. Forwarding A, and let's give it an IP address. So IP address 10.5, or actually 10.0.0.5. Now, one thing about these loopbacks here, and let me write that here as a prerequisite, I forgot to mention that. So new loopback interfaces on P routers in VRF, and these must be on separate subnets. The best way to ensure that is to actually use them as /32. Now, in some versions of iOS, there is actually a requirement for this to be /32, but I haven't seen that in recent days. So the next thing that we need to do here, it says the loopbacks must be advertised into MPBGP, but not in OSPF. Now, this not in OSPF is the step that is usually not mentioned in these steps here, but I have seen situations when OSPF router, when PE router would refuse to even initiate the sham link if it had the endpoint of the sham link in OSPF database. Now, to avoid that situation, this is why I personally like to take extra step to ensure this doesn't happen. So here I'm going to create a prefix list, and I'm going to call it sham, and I'm going to say permit 10.0.0.5/32, and I'm also going to permit the other side. Now, then I'm going to have a route map, which is going to be BGP to OSPF deny 10, and here I'm going to say match IP address, prefix list, sham, and then I'm going to permit everything else. So basically, know that there is a redistribution between BGP and OSPF, which I'm going to keep in place. And what I'm going to do is I'm going to prevent these loopbacks from actually making it into OSPF. I'm not going to be redistributing them there. Then I'm going to say router BGP 56, address family, IPv4, VRFA. And here I'm either going to redistribute this loopback or I'm going to advertise it with the network statement. So I'm going to say network 10.0.0.5 mask. And finally, here I will have router OSPF, and this is on R5, so this is going to be 57 VRFA, and I'm going to say redistribute BGP 56 subnets route map BGP to OSPF. So I want to have that in place, so I can maybe just resize this way. And then at this point, I can build the sham link. So I'm going to say area 0, this is where I need the sham link. Sham link, I specify the source 10.0.0.5, destination 10.0.0.6, and I can specify the cost. If I don't specify the cost will actually be 1. So this is the configuration of the sham link on R5. So I'm going to go to R5 and going to paste this in. So now when I pasted this in, on R6 here, if I do show IP route VRFA, I should be getting the route for R5's loopback. So let's see, maybe it just takes a little, there we go. So I'm getting the route for R5's loopback. So let's do the same configuration for R6. On R6 side, there are a couple of changes. So this is VRF forwarding because of the new configuration. And this is going to be 6. Everything else remains pretty much the same until this point where this changes to 68. Sorry, this changes also to 6. And this is now reversed. So I'm going to go to R6 and I'm going to paste this in on R6. So now when this is in place on R5, if I do show IP route VRFA, I should be getting at some point soon enough. There we go. I should be getting the route from R6, so there it is. And I can see here that there was a log message that the neighbor actually came up on the shemlink. So if I do on R5 show IP OSPF 56 neighbors, actually 57, sorry, neighbors, I should be seeing the neighbor here on the shemlink. And I can see that that neighbor actually used some other router ID from before. But remember, router ID is not an IP address. So this here is actually R6, and I can see that we are now neighbors on the shemlink. So if I go to R7, and if I do show IP route OSPF now, take a look at the path that my traffic to R8 is going to take. It's going to take me directly through my MPLS backbone. So if I do a trace route to here, I can see that it actually goes across the backbone. So problem solved. Not so fast, because on R8, the problem still exists. The reason why this actually worked on R7 was this, right? So this is that last step that I mentioned, that you might need to do some cost modifications. Now I'm in a position to actually solve this problem, because now I'm actually getting an intra-area route from my super backbone. But on R8, this still has higher cost than this direct link. So I'm going to go on interface fastness 01, I'm going to say IP OSPF cost 10. That should be more than enough. And I need to wait about 10 seconds before I check for the route. So about now, oh, and I got it spot on. So here on 10007, now we can see that it actually goes through fast Ethernet 00. So now we are in position and we can see the actual difference in metric. So here the metric is 2 and here the metric is 4. So this is the reason why I needed to change the cost. So now the traffic is actually going to be going across the MPLS backbone in both cases. Now, take a look at the difference in trace routes. And this is really interesting because I actually forgot that we've done that. Now, remember some time ago, we actually configured on R5 this command here. No MPLS IP propagate TTL forwarded. So this is now configured. Look at the trace route. Here we are seeing 5 and immediately we are seeing 6. But on R6, we don't have that configured. So when I do the trace route from R8, basically I'm seeing a much longer path here. I'm actually seeing my R2 and R4 in place there, and they are actually showing me even the transport labels that were used, and I'm seeing the actual VPN labels that were in use.